Hi, in this video, I will go over the answers to quiz review number 1. In the first question, we have to construct a categorical frequency distribution. So the process is we have 4 columns. In the first column, we list each category. And in this case, there are 6: candy, chips, cookies, donuts, fruit, veggies. Then we look back at the original data and we place a tally mark in the category that each data value belongs to. So for example, chips, we would place a tally mark for chips. And then we would repeat that for each of the data values. Once that's accomplished, we then add up all the tally marks. So for candy, in this data set, there are 7 people that chose candy as their favorite snack. We would then add up all the marks to get 7 for candy. Also for chips, it's 7. Cookies is 5. Donuts is 5. Fruit, 4. Veggies, 2. Next, we calculate the relative frequency. To do this, we have to find the sum of all the frequencies. And that sum is 30. After we find the sum, we then divide each frequency by that sum. So for example, 7 divided by 30 is equal to 0.23, and it repeats. Well, for the relative frequency, we just round to 2 decimal places. It would round to 0.23. And that would be the same for chips. Let's calculate it for cookies. Cookies, we would take 5 divided by the total 30, round to 2 decimals. So in this case, we round to 0.17. And then we repeat the process for the other frequencies. We could also convert these to percents. You would just have to multiply by 100 to do so. And that's the categorical frequency distribution. Next, we have to find a grouped frequency distribution for this quantitative data. And we desire 7 classes. So the first step is to calculate the range. The range is the highest value, 118, minus the lowest value, 28, which is 90. After we calculate the range, we calculate the class width by computing 90 divided by 7, the number of classes. This is 12.857. Remember, we always round up to the next whole number to find the class width, so it rounds to 13. When building the classes, we always start with the lower limits. We select the first lower limit, 28, and then we repeatedly add the class width, 13. 28 plus 13 is 41. 41 plus 13 is 54, and so on. After we generate the lower limits, we focus on the upper limits. Subtract 1 from 41 to get 40, and then once again, we add the class width. 13 plus 40 is 53. 53 plus 13 is 66, and so on. So when we have our 7 classes organized, we should make sure that it contains all the data values, and it does. Our next step is to calculate the class boundaries. Now the lower class boundary limit is found by subtracting 0.5 from the lower limit. So 28 minus 0.5, 27.5. The upper class boundary limit you add 0.5. So 40 plus 0.5 is 40.5. And then we repeat that process for all the lower limits. Subtract 0.5 to the lower limits to get the lower class boundary limits. Add 0.5 to the upper limits to get the upper class boundary limits. Next, we have to tally the data. So we go back to the original data set. Let's look at 63. We have to see which of these classes does 63 belong to. Well, it's going to be the third class. So we would place a tally mark there. And then we just repeat that process for the other values. 46, that belongs to the second class. And we will tally all the data values. Finally, we add up the tally marks to find the frequencies for each class. So there's 4 values in the first class, 3 in the second, 7 in the third, and so on. This is the grouped frequency distribution. Our next step is to graph the group frequency distribution. To do this, we place all the class boundary limits on the x-axis. I like to focus on the lower limits plus the upper limit because these are repetitions. So we list the class boundary limits on the x-axis, list the frequencies on the y-axis. Now for each pair of class boundary limits, we're going to construct a bar with a height equal to the frequency. So for 27.5 to 40.5, we have a height of 4. For 40.5 to 53.5, we have a height of 3. And we repeat this for all the other frequencies. Remember, the bars must touch for the histogram. Now we move on to the second graph, which is the frequency polygon. So the frequency polygon, we have to create a new column for the midpoints. So the midpoints is calculated by adding the 2 class limits and then dividing by 2. So let's first compute the very first midpoint. To do this, we take 28 plus 40, which is 68, divide by 2, 34. Now we could repeat that process for all the other midpoints, but remember the classes are separated by the class width, which is 13. That means the midpoints are also separated by 13. So we add 13 to 34, 47, add 13 to 47, 60, and so on. And that's a shortcut to rapidly compute all the midpoints. Now, to plot the graph, we use the midpoints as x-coordinates, frequencies as y-coordinates. So at 34, we go up to 4. At 47, we go up to 3, and so on. We connect all those points with straight lines. The final step is we have to anchor the first point back to the x-axis. To do this, we need to find a hypothetical midpoint. So remember, the midpoints in this example are separated by 13. So we subtract 13 from 34 to get 21, anchor. On the right side, we have to anchor to the right of 112, add 13 to 112 to get 125, and we anchor it, and we have a frequency polygon. Our next graph is the ogive. Now, to graph the ogive, we have to construct a cumulative frequency distribution. Once again, we list all the class boundary limits like we did previously for the histogram. We have to find the sum of all the frequencies that precede each limit. Well, if we go back to our table 27.5, there are no frequencies that precede it, so we always begin with 0. Then we go to 40.5. The only frequency that precedes it is 4, so we put a 4 next to it. For 53.5, there's two values that precede it, 4 and 3. That's going to give us 7, and then we just repeat that process. For the last limit, it's the sum of the entire frequencies. Once we have our cumulative frequencies, we're now ready to graph. We put the class boundary limits on the x-axis, cumulative frequencies on the y-axis. I went by units of 5. We plot our points. At 27.5, it's 0. 40.5, it's 4. 53.5, 7. And so on. The final step is to connect all the points with line segments. And it's only anchored on the left side and should always be increasing, never decreasing. If your ogive is decreasing, something went wrong. Now let's take a look at the pie graph. Now for the pie graph, we're given the different elements and their percentages. So to find the degrees, all we have to do is multiply the decimal version of the percent with 360. So for example, 65% is 0.65, and we multiply with 360. That's going to give us 234 for oxygen in terms of our angle for the section. For carbon, we multiply 0.19. Remember, 19% to convert it to a decimal, just move your decimal 2 spaces to the left and drop the percent sign. And then we multiply that with 360 to get 68.4 degrees. So once we have our degrees and our percents, we can then draw each of the sections for the pie graph. You could either use your degrees or your percents, whichever you feel most comfortable with, because I'm not expecting people to be able to construct it using a compass or protractor. So if you're drawing this by hand, you just want to get it as close as possible to this graph. Now the final graph deals with the Pareto chart. So remember, with the Pareto chart, you always want to make sure you put your data values in order from the highest to the lowest. And our categories are different types of fast food restaurants. Next, you place your categories on the x-axis, frequencies on the y-axis. Remember, the bars do not have to touch. So for the first category, Chick-fil-A, 34 people really enjoy eating there, so we draw a bar with the height of 34. In-N-Out, 28, draw a bar, and repeat that process for the other categories. And then you can determine that the two favorites obviously are Chick-fil-A and In-N-Out. And so that's just a review of potential problems you may encounter on this upcoming quiz. Thanks for watching the video.